Now we are moving on to a panel. So this panel is on how and when will deep tech increase the longevity of humans? Who wants to live healthier and longer lives? Recent advancements in visual technologies, machine learning, and artificial intelligence will increase human longevity. Solutions ranging from analyzing health records, blood results, physiological test scores, body scans, biotechnologies, and even genetic tests will be a game changer on longevity healthcare. Whether you're looking to optimize your performance, be that physical or cognitive performance, or interested to learn about longevity medicine able to push the limits of the human lifespan, this panel will cover that and more. So it's my pleasure to welcome our moderator, Dr. Jack Kreindler, co-founder of Certific, and he will introduce himself and his panelists. Thank you, Jack.
Thank you very much, Evan and team. It is always a privilege to be invited to moderate an esteemed group of people, two of whom are close friends, and very great pleasure also to meet Kristen as well. All three of these panelists, their work I'm in admiration of, and as someone who is a physician now 25 years in practice, so I guess I'm not a junior doctor anymore, and pretty well 20 of those years have been in what is now being coined kind of longevity or health span science. It is great to be able to take three of these wonderful people who are doing great work and be able to share some of their insights with you all. So I'll give my own in the mini intro to our three panelists, and then I'll allow them a little bit of time before we dive in to give their own little intro. So first of all, Dr. Daniel Kraft, I met Daniel in 2012. He's the chair of NextMed. I met him whilst he was chairing the Singularity University Medicine division. He is a tour de force and very well known throughout the world in all things cutting edge. And he was pretty well the first person that inspired me to think properly outside of the box. Very Californian style, to kind of think, well, what is it that we can do in the field of medicine that I'm in, and to take that and actually try and do things at a system scale. So now we have a lot of people in the UK, which is where I'm based, attending Daniel's program and learning a lot and actually doing system-wide stuff such as the NHS Clinical Entrepreneurship Program. So that's thanks very much to Daniel for doing that and helping me get a lot of jet lag from an awful lot of flights to the US. So hopefully we can combat that with some anti-aging stuff. Secondly, Michael Geer. Michael is a social network guru, who's turned his efforts towards humanity's greatest challenge. His project is called Humanity, and it is entirely focused on ways in which we can universally get people to live healthier, longer lives. We met through my work with an investor quite a while ago, and Humanity has done some amazing work and recently published a very interesting paper that it was involved with, looking at optimizing biological age measurements with very, very simple blood tests. And I'm very much looking forward to learning a little bit more about that, actually, Michael, as time goes by. Kristen, I've always been a fan of BioAge. We've never met, so it's great to meet today. Kristen is the CEO and co-founder of the clinical stage biotech company, which is singularly focused on aging itself, and very much a pioneer spearheading this sort of pharmacological movement towards us actually treating aging as a disease. So this is my little intro to these three fabulous people. I'll allow them, let's say, should we give you guys 60 seconds each to go from birth to now and how you got here? Maybe 60 seconds would be a bit much, but starting with you, Kristen, tell us your story and why it is that you're now where you are and focusing on what you're doing.
Yeah, for sure. No, thanks for having me. You should really have a timer. You'll have to let me know.
I'll wave like this when the time's coming up.
But yeah, personally, I've been focused on aging science for a very long time, really since graduate school, because I was really inspired by and excited by some of the advances made there, right? Like we've been able to, by modifying genes or by modifying drugs, make animals live a lot healthier, a lot longer. And if that could translate to humans, the results would be amazing. So my work at BioAge and the founding of BioAge was really inspired by human examples that we can all live better longer, right? Like if you just look at the 8 billion experiments on the planet, there are already a lot of people who make it to age 100 or 110 even, and their muscles still work pretty well, their brains still work really well. So what can we learn about their biology that will teach the rest of us how to age better longer? So what we're focused on at BioAge is as a platform where we're measuring, tens of thousands of molecular variables from thousands of human experiments and asking the question, what differentiates those people who age well from those who age poorly? And that's where the machine learning comes in on our side. And then based on those hypotheses that we learned from human data, we're executing on those targets now in the clinic.
Thank you. Michael.
Yeah, so 60 seconds, let's see. Wanted to be an astronaut, decided to go to Moscow to see the other side, met a guy, we started a dating site that became the largest in the world. Unfortunately, then had a relative basically find out stage 4 about cancer. And that kind of, threw me for a loop. So I started looking at preventative health. In the meantime, went out to the Valley to take over operations at a consumer VPN that we got to a massive scale, protecting the internet. But very serendipitously, when I was out there, I met amazing people, one of them being Kristen, kind of turned me on to the idea that you could look at these longitudinal data sets that you just spoke about. And there's something better than even early detection of disease, is you could actually see the whole body or the body systems moving towards disease. And so at that point, knew that I needed to kind of jump in and do my part. And so really Humanity allows you, it's an app that allows you to monitor your rate of aging and then guides you to slow it down. And very much we see our role as bringing all the kind of new knowledge and old knowledge in the longevity space, bring it to everyone. So, health equity is kind of a newer coined term, but that really just, let's bring all this knowledge that we have so that everybody in the world can start benefiting from it. So.
Thank you, Michael. Thank you for making that jump. Daniel.
Hi, Jack. Good to see you all. So my 60-second story, I sort of trained as a traditional physician scientist. After med school at Stanford, I did medicine and pediatrics, then came back to Stanford and did hematology, oncology, stem cell biology and regenerative medicine, and got more involved in digital health and the convergence of technologies, and thinking about the future of healthcare, partly through my role chairing medicine at Singularity University and building a program about the future of healthcare, where a lot of people in the Valley are interested in super longevity. I'm more interested in sort of in health span. No one wants to be 120 and feel 120. I was just with my wife's grandmother, turned 104 in Jerusalem. Lives in a pretty incredible community that highlights the importance of the sort of the social determinants of aging as well. But as Jack, you've been to early NextMed health programs. I think the interesting part in health span longevity is this convergence, whether it's your digital biomarkers, your aging clocks, the ability to understand your base genome and multiomics, kind of putting all these dots together and layering them up. Maybe it's the digital twin, et cetera, where the future of health span, health equity all comes together. And I think part of what we'll talk about today.
So right now, I know it doesn't look like it. I'm actually in the middle of the deep French Alps on teaching on a mountain medicine course where we've just been digging people out of avalanche scenarios where unless you do the things right, you end up dying within 15 minutes, not 150 years. So there is a very in my profession as well, there is a difficulty in kind of understanding the power of AI and ML and a lot of the stuff that you guys are working on as a practical thing, when so many other things are happening. And this wouldn't be an LDV talk, of course, if it wasn't related to visual AI and machine learning. So with that in mind, how are you seeing some of the breakthroughs in visual biosensing and non-invasive measures, for instance, for detecting disease and helping people like Dr. Jack, maybe not in avalanche scenarios particularly, but in helping my patients stay healthier for longer? I'll let any of you go. Let's just riff on this.
I'll start with a couple quick examples. I mean, now you don't need to be having any sort of wearable. Your camera on your laptop or your phone can pick up your your vital signs. We actually did a NextMed Health 2 weeks ago. We crowdsourced everyone's vital signs before and after music and showed everyone's heart rate variability and stress levels, etc. So you need to be wearing anything, and obviously see the camera on your phone can now pick up laboratories or digital pathology, as we saw. So I think the whole optical visual world layering with AI, machine learning, and crowdsourcing is going to get super interesting. And it could be not just your vitals, but are there any droops in your face or changes in the sclera of your eye, or adding in the voice as a biomarker? Again, not any one component, but that's moving very quickly. And with the ability to connect the dots and connect that to actionable information will impact a health span.
Yeah, there's a very interesting wearable around the wrist that uses optical sensing to continuously measure blood pressure, which I think is a very kind of practical thing, which is not only related to longevity, but of course to standard measures, which doctors are rewarded for measuring as well. So that's a very good point. How about in the sort of area of, Kristen, in the area of like discovery, in fact?
Yeah, just to comment on what you mentioned, right? I mean, medicine today is very reactive. Like you're in an avalanche, or you present at the hospital and you're very sick. You're very bad cancer, or late stage Alzheimer's disease. And what we've learned for these big killers, whether it's Alzheimer's, heart disease, cancer, that's too late. We really want to intervene earlier. And part of the reason I'm so excited about aging biology is because I believe that's the way we can really like unlock true preventative medicine. And the other side of that, though, is that there has been this big obstacle in the past. Why don't we have preventative medicine, right? Like, why aren't these things being rolled out? And part of that is related to the measurement technologies that we're discussing here, right? Like, you have to be able to tell on a short time scale whether you're impacting the phenotype, whether you're getting healthier, whether you're, really reducing your risk of disease, whether you're intervening better. And I believe that some of these technologies that we've discussed, whether it's wearables or cameras, or the stuff that Mike is building, is going to help unlock that. And the time for that is really now.
Yeah, absolutely. And before moving on to Mike, I think that is obviously a challenge in your area is, how do you tell 50 years in advance that the phenotype is actually going to be a healthier, longer living phenotype with the drugs that you're, right.
So I'll tell you how we very specifically think about that at BioAge. So we're betting on pathways that are predicted and related to longevity over decades. But of course, when we go into the clinic, we can't do a 20-year clinical trial. Like that would be well, terrible.
You can, but we'll all be bankrupt. But yeah,
we'll be bankrupt. And things fail in the clinic for a million different reasons too. You really want to know really quickly whether it's doing what you think it does. So the way that we approach that at BioAge is we go after a very specific disease first, so we can run and part of the whole focus on aging is that these drugs that really slow your rate of aging are going to be curative for some diseases of aging. So that path is open, right? So we like to focus on specific diseases first. But at the very same time, in our clinical trials, while they're very focused, we can start to look at some of these biomarkers that are related to more like lifetime outcomes, right? So for example, a clinical trial that we just did a press release on in December, we have a drug that slowed muscle atrophy in older patients. And that was, that readout is related to some very practical diseases in muscle atrophy. But at the very same time in those patients, we went in and did multiomics, including the proteome, and saw that the rate of aging was also impacted. So you can get a clue early on that it has this broader impact.
Right. Michael, obviously, this is kind of the crux of what you're doing, is to give people the biomarkers of aging. So how are you seeing the future of this domain as it becomes more and more important that we have accurate measures that predict the future many decades in advance?
Yeah, I think we've all seen this year that, with Chat GPT and everything, I think everybody now has the concept, or more people have the concept that we can predict the future if we have enough data. And we can do, amazing things that seem like magic. I think the thing that makes, predicting the future, say in the drug discovery sense, as Kristen is doing, you guys just laid out why it's very important, because you need to figure out if something's working or not. For the user, for the person, for the patient, however you want to call them, I think there's been a nihilism in health where, people said, a bunch of people just don't care about their health because I tell them what to do. They leave my office, they leave the doctor's office, they just don't do it. But we always kind of knew or at least our hypothesis was, coming from, as you put it, like social network guru, like coming from like social networks and, the Instagrams and the, what I did Badu, we knew that we could change people's behavior. And many times that's in a bad direction, especially in Instagram. But we knew that we could, so there was never any doubt. And so the question is, what's the feedback loop? And so our hypothesis is if you give that feedback loop of, hey, your future health is changing, your biological age is getting better or worse. If we gave that quicker and we updated it more, then you were going to see a change of behavior. And that's what we've actually seen with the Humanity users. We have about 150,000 users so far. We could actually see that, it is changing behavior. And so I think that's maybe the positive message to give is it will change behavior if you give people a good feedback loop. And, the visual technology is allowing that, as you guys covered well, to really kind of, democratizing and get out to more people. I think we're going to see the, glucose switch from the cool, but not as spreadable, continuous glucose monitors to the visual. There's a lot of stuff, like you said, blood pressure. So yeah, I think as long as we're all kind of open to, bringing these things into our everyday practice and getting more people in the world to start using them, that feedback loop is effective. So.
I mean, there is for me, amongst many of my colleagues as well, a kind of a challenge even in dealing with the very, very basics of, a very burdened health service with enormous amounts of existing morbidity and, problems that are definitely going to foreshorten folks' lives. And yet on the other side, we're talking about the behavioral change in people that are not yet manifesting, frank disease as we, as me in my clinic would normally diagnose something when we can then prescribe something that's reimbursable. So I just wanted to spend a little bit of time talking about the kind of shift from reactive to proactive, and how is it that I am going to start prescribing some of these things? Because I mean, I honestly, you know full well that I believe in the vision, but I also know the pains and the tribulations of my everyday life and of the lives of the colleagues like me. So what are the biggest things that we can do using technology that can make the shift as quickly as we're making the scientific discoveries?
Well, part of it, of course, is aligning the misaligned incentives. Most of what we practice is the sick care equation for folks who already have advancing disease rather than rewarding prevention, proactive health span. These technologies are still often expensive. I just had a full body MRI scan from Pronuvo and had a clearly hard scan and everything looked pretty clear. But, those are a few $1,000s. Those will potentially get cheaper and more democratized. Or like our friend Mary Lou Jepson, you put a little wearable in your head and it can scan your brain for cognitive and neurologic challenges. So part of it is aligning the incentives, the payment models, and the workflow of the clinician so that they can prescribe proactive elements, whether it's a multiomics or have an ability to be rewarded for looking at your digital twin and tweaking your H score or your longevity program.
Yeah, right, absolutely. So how can we get the people that end up paying people like me, to make, how do we best make the payers and the people that do the reimbursements incentivize me? How do we get that happening more quickly is one of the most pressing questions in conversation today.
The short answer is follow the dollars. I mean, I'm on the board of a company called Healthy.io. They use your smartphone camera to diagnose early kidney disease, and the NHS and now US Blues programs are paying to do a screen on your phone of your urinalysis to pick up early proteinuria, which means you might end up with kidney disease and you can avoid dialysis, et cetera, if you are proactive. So some of it is that show me the money, and that's where money still speaks. True. So that we have to sneak in the health proactive side into the sick care side of the equation.
Which, by the way, just talking about that particular project, that particular company is an extremely good example of visual AI and how it's become something that's reimbursable and has been proven. But I think, systemically, I mean, that's still dealing with non-aging type. It's still dealing with kind of like, UTIs and stuff like that. So I'm just wondering if we, if we as people in the world of technology and in medicine, what is it that would be able to accelerate this change that we need to see?
I think so. Maybe I don't think it's a radical thing. Actually, you guys are probably more radical than me. you know, a lot of this stuff can be free or near free. You know, you can use Humanity for free, and then you want some premium features, you pay, you know, a few bucks a month. I think that onboarding, I'm not saying all things can be, you know, helped by that, but like that onboarding of getting used to, I'm monitoring myself for free or near free. And then, you know, if something gets picked up or if I, you know, people get into a habit at that point. And so that on-ramp is, I know you were asking more like, how can, you know, doctors kind of engage more, but I think people will engage more when they get used to this feedback loop and seeing that what they do makes progress, because everybody actually wants to be, almost everybody actually wants to be healthier. And so if you reduce that effort, make it free or near free, at least for the on-ramp into that kind of process, people will start doing it a lot more, and it will lead to, I think, the system, you know, picking up some of the costs as they get larger.
We've been talking about tools, but really a lot of the same arguments apply to therapeutics, right? Because ideally you would want, do you really have an aging drug? You'd like to be able to prescribe it to anybody and have, you know, Medicare pay for that, right? So how do we get there? How do we get to a world like that? And part of it is going to be regulatory change, right? Like, as I mentioned at BioAge, we're focused first on getting to, you know, one particular disease approval. In the future, we would like, you know, our aging drug reimbursement to look more like a statin, right? Like you can go out and prescribe a statin to pretty much anyone when they're not already sick, when they're, you know, 40 or so and have some risk biomarkers. And so we know that we can do that, like with today's FDA and regulatory system and payer system. It did take 20 years for them to do the label expansion, you know, from one orphan disease to sort of really broad treatment. And so I think it is really interesting to think about how we can do that faster. And I know that, and it might not be the US that does it first, right? Like, as you mentioned, for the tools, if you can show the payers that it's going to cost them less, they will do it, right? But you do have to make an investment to get to that point. And who's going to make that investment? And there are, you know, the EMA in Europe, for example, is much more willing to consider clinical trials and think about reimbursement for drugs that are related to frailty and sarcopenia, like just muscle loss more broadly, which is still a more novel concept here stateside, and Japan as well. So I think that there's going to be, you know, there's an opportunity here for innovation that might happen with a different healthcare system in a different country. And then once someone's done the proof of concept and shown that it can save money, these things will save money, there'll be a broader rollout.
Well, interestingly, the UK was one of the first people to take on the real pharmacoeconomics, or the real rather diagnostic economics of the Grail-Galleri test. You know, I think that it shows that things will eventually get rolled out when you prove the economics of it. But interestingly, Kristen, you just mentioned statins in a moment ago, and news just out is the huge deal of inclisiran for all people with resistant hypercholesterolemia, which I think we all know that people who are resistant to any form of behavioral change will do very, very well from a once every 6 months jab of a PCSK9 inhibitor as an alternative to trying to force people into taking drugs they don't want to take and so forth. And yet it was the GPs who said that this was too much of a change in what they do, and they were nervous about you know, the logistics of bringing people in once every 6 months to give them a jab, and hence that's why, you know, Novartis has pulled out of that very, very big deal. But that would have been a huge thing for cardiovascular disease and aging. So yeah, I agree with you, but not wanting to be argumentative about it. I think that, you know, here's an example of a cost-constrained health system that is well known throughout the world as being a place where you can prove these things out, and yet, you know, we see a turnaround in this direction. I just wanted to make that point about it, because I think we do have to work harder to show the payers and the doctors and the patients, you know, the proof that this stuff really does work.
No, that's right. It hasn't been easy, right? Yeah, someone has to make the investment. Yeah.
Yeah, we're on 25 minutes, so we've got 30 minutes on the clock. Just like life, things do run out of time. But I'd like to just leave a little bit of time for Q&A before closing. I don't know how we're doing Q&A. I'm looking at the magic screen where we're told lots of things.
Hey, Dr. Jack, you can keep on going for another 5 minutes. If Q&A comes in the chat, we'll mention it. But why don't you and the panelists finish some closing wisdom?
Great, the closing wisdom. Okay, well, the usual way that I like to end is just give you guys a minute to think outside of what you are particularly working on yourself and what you are seeing outside of your particular domain of work or interest that is truly groundbreaking, something that is making your eyes open and your heart beat faster in this domain of longevity medicine. Michael, do you want to start?
Yeah, I think the thing that is fascinating me now is the ability that we're starting to have to we can create synthetic data from real data, not just for augmentation of the data, but actually create from a large real set a synthetic set. Federated learning, meaning all the data stays where it is and you train the models locally. I think now that we have, it's great when you have things, not to repeat it twice, but it's great when you have things like Chat GPT that just reminds everybody of, hey, if we had the data, we could do amazing things. And I think that we'll see in the next year that's been a big push for now. Hey, if we have the data, we could predict a ton of stuff. And I think the allowing for the privacy preserving, so keep the data ownership of the user, privacy preserving, but still learn from it, still train models on it. That now is a possibility. And so watching that progress is really interesting.
Kristen.
I've been really excited to watch recent developments in neuroscience, which is, again, very much like a visual problem, right? You can do sort of spatial omics now. You can take like really thin slices of brain and look at what's going on. And I'm particularly interested in this from an aging perspective, because that's who you are. Like, that's kind of the scariest component of aging is just losing identity. And there's just been so many new tools there. And again, like there's so much data that didn't exist before that is enabling sort of new knowledge. So that's not something we're working on directly with those kinds of images, but I'm watching progress there with a lot of interest.
I think when we think about future longevity and aging, we need to think about, true personalized precision prevention and health span, because we're all built a little differently. And I think the things that are getting exciting now in this exponential age is now the ability to do essentially Theranos for real, multi-omics from a drop of blood from your finger every hour, like Mike Snyder and Stanford published a couple of months ago, combined with wearable data to give incredible insights into physiology and impact of everything from exercise to nutrition to sleep. Things like phenomics, like the work of Leroy Hood, who's the father of P4 medicine, precision, personalized, proactive, participatory, starting to crowdsource and connect all those dots. And so I think we need to enter this age where it's not going to be any one intervention, one age clock, but the ability to kind of truly tune that to the individual proactively early in life, when you sort of have that check engine light, 20 years before you have dementia or cardiovascular disease or cancer, and to build those with synthetic biology, the precision vaccines against Alzheimer's or cancer, and or the cocktail of meds that you might 3D print at home that are going to be your true personalized proactive health span longevity cocktail. So it's connecting all these dots, and now we're sort of at the ability now not just to create data, but insights, and then translate those insights into true action at the bedside or now the website.
If I was to have interviewed you guys 5 years ago, I would not have felt as confident that we were on the road to implementation of this stuff and getting rid of the old neurons in my brain that kind of just stick towards reactive medicine. And you are right, Daniel. I think, one of my takeaways is that the vital sign stuff is actually here. It's really happening. The evidence is growing that things that pharmacologically or behaviorally improve our chances of longevity also improve our health as well, which is very much in your area, Kristen. And Michael, I think, my big takeaway from your work, seeing it grow over the last few years, is that actually people can do an awful lot. You don't need the profession, or at least the people will educate the profession. But overall, I'm feeling very much more positive that my clinical work will undergo a transformation thanks to the kind of work and that you guys are spearheading. So thank you very much for that. I'm also very grateful to ChatGPT, because otherwise I would have to have been here in person. But of course, I've just been, leaving it to the synthetic video production to represent me, and I hope it did a good job. But anyway, thank you very much, all three of you. Thank you very much, Evan, for giving me the opportunity to interview these three brilliant people. And I hope the rest of the day goes well.